going to discuss about chapter 5, hydrocarbon, which is in our group assignment. Let's start with introduction of our team. So our team consists of two persons, which is Muhaimin with Zubir and me, Abdul with Shahrudin. This presentation consists of two tasks, which is task 1 and task 2. These two tasks is based on chapter 5, hydrocarbon only. Task 1 is about synthesis and reaction of organic compound. Task 2 is about finite component assessment. So let's move on with task 1. Okay, task 1, the structure of compound 1, 2, 3, and 4 as shown below. Give name to all structure 1, 2, 3, and 4. So let's move on with structure number 1. You can see that here there is no double bond, and it has 1, 2, 3, 4, and 5 carbon, and we can identify that this compound is alkane because there is no double bond, and we know that 5 carbon is pentane. Here is pentane. So number 2, structure number 2. Let's count the longest chain that this structure have. 1, 2, 3, and 4. So this pipe, this C here, can be branched into two pipes, which is here H, bond with H, and bond with CH3. So the longest chain is 1, 2, 3, and 4, because this methyl will be here. So 4 with branch of CH3 here. So the numbering for methyl is 2, because we start from here, 1, 2, the smallest numbering. So 2 methyl, 1, 2, 3, 4, 2 methyl butane. So this is the answer. Proceed with number 3, CH3, CH2, CH2, CH3. So this here have a 4 carbon, and there is no other bonding like structure number 2, and there is no double bond. So this is alkene, and we know that when 4 carbon is a butane here. And the last one is CH3C, CH32, CH3. So here in this C, there is 2 bond. If we expand it, here will be CH3, and here will be CH3. So we want to figure out what are the name. So we need to count the longest chain of carbon. So if we count from here, 1, 2, 3 is 3. 1, 2, 3 is also 3, and 1, 2, 1, 2, 3 is also 3. So if you count from all sides, is 3, but we must consider the most substituent. So here have 2 substituent, which is methyl. So we start from either side, which is we can start numbering from here or here. So 1, 2, 3. So we got 2 dimethyl here. This is methyl and methyl. So dimethyl. 1, 2, 2 dimethyl propane. Just like this. So that's how we got it. Task 1 is arrange these compounds in the order of decreasing boiling point. Explain your answer. First, this is our answer. Pentane, 2-methyl butane, 2,2-dimethyl propane, and lastly butane. So we want to do some explanation in the next slide. Alright, this is the explanation. More carbon in structure means more bigger the molecular size. So we must identify which structure have more carbon. So pentane has more carbon and bigger molecular size than 2-methyl butane, 2,2-dimethyl propane, and butane. 2,2-dimethyl butane is more bigger than butane because it has 5 carbon, but butane has more carbon. The bigger the molecular size, the stronger the intermolecular forces, resulting a higher boiling point. The stronger intermolecular forces means the stronger forces needed to break the bond between the particles. So pentane has higher boiling point than 2-methyl butane because pentane has greater dispersion force. The molecular are longer and so set up bigger temporary dipoles and can lie closer than the shorter, fatter 2-methyl butane. Pentane and 2-methyl butane has higher boiling point than 2,2-dimethyl propane because 2,2-dimethyl propane has increased in number of branch chain. With increase in branching, the surface area of the molecule decrease and the van der Waals force of attraction decrease also, which can only overcome at relatively lower temperature. So that's how we identify which particle or which compound have higher boiling point or lower boiling point. So task one, next question. Identify the compound that give only one product of formulation. If condition of formulation reaction and name of type involve show the reaction mechanism for the formation of the product. So if we expand all the compound that we got, we identify as this compound give only one product of in the formulation reaction. Because when we expand the structure, we can get C, the center of Z is 4 degree, 4 degree, the fourth degree carbon, and the other one is 1 degree carbon because there is only one bond with the carbon, and the C at center bond with for another 4 carbon. So there is only one product of elimination here. So the condition of the reaction is in the presence of light or temperature greater than 100 degrees Celsius, and the type of mechanism that we choose is free radical substitution. So the reaction of mechanism formation are in the next slide. Formulation consists of three steps, which is the first step is initiation step, the second step is propagation step, and the last one is termination step. So we have learned all these steps in our last lecture, our lecture before. So I hope that you all understand about this drawing and how we got this structure and how we do this step and how we did this step. So let's move on to the task two.
Move on to task 2, which is INEC component assessment. INEC stands for integration, nuclei, and alkali. This is the question for task 2. So for task 2, our group has to choose a plan based on the functional group presented, and the plan is related to chronic verse. So our group has choose bananas as our chosen plan based on the functional group hydrocarbon, and the related chronic verse based on the bananas is Surah Al-Waqi'ah at Surah 56 at verse 29. Water mansut, and that means and bananas trees layers with fruits. So what is the structure of the bananas? Many chemical compounds detected in banana fruits, such as carotenoids, flavonoids, phenolics, amines, vitamin C, and vitamin E, having antioxidant activity to provide many human health benefits. Banana also can produce ethylene gas, which is commonly known as ethylene. Ethylene is one of the hydrocarbon that acts as important hormone that produced when the banana is ready to ripen. Is the composition of the bananas. One serving of one medium ripe bananas provide about 110 calories, 0 gram fat, 1 gram protein, 38 gram carbohydrates, 50 grams sugar naturally occurring, 3 grams fiber, and 550 milligram potassium. According to the data obtained by the study, total aromatic concentration was higher in naturally ripened bananas compared to that 50 of the ethylene-treated bananas. Ethylene concentration is 100 until 150 part per million according to the stage of bananas. Here's the structure of ethylene or ethene. It has two carbon, which is ethene, and it has double bond, which means Na. So we can call it ethylene. Next, what is the benefit of bananas? Bananas may cure many diseases, and especially recommend for fever, digestive system disorder, cramps, and muscle slackness. The vast amount of potassium that is contained, which is 0.24%, facilitates the excretion of waste product from the body. Bananas also decrease blood pressure and also used to treat allergies. Their potassium function together with sodiums promote cell and muscle developments and regulate the body water equilibrium and heartbeats. Next, the reaction of ethylenes. Ethylene can be prepared from reaction of synthesis of ethylenes or dehydration of ethanol. So this is synthesis of ethylenes. We use the dehydration of alcohol. We use ethanol at high concentration and H2SO4 to produce ethene and water. Next. Next is the reference that we use to do task 2. We use Al-Quran, books, and some website that we search on the internet. So we have come to an end of our presentation. Thank you and see you next time. Bye.